All right, let's talk about building with AI. If you've ever worked with it, you know the feeling, right? You get this awesome demo working, it feels like magic, but the second you try to move it towards production, it just falls apart. Today, we're going to dive into a framework that's designed to get us past all that frustration to build AI apps that are solid from the jump.
So let me ask you a question, especially for all the builders out there. Is vibe coding holding you back? You know what I'm talking about. That super fast, exciting, rapid-fire prototyping, where you just kind of tell the AI what to do, and poof, code appears. It feels amazing, it feels like the future. But the real question is it built to last? You know, Andre Karpathy actually put a name to this whole thing, vibe coding. And look, it's incredible for spinning up a proof of concept in just a few minutes. But that magic, it wears off really fast when you try to scale. And the reason why is almost always the same, a serious lack of context. That's what leads the AI to make weird mistakes or just hallucinate things that aren't real.
And this isn't just a hunch. Check out this number, 76.4%. That's how many developers say they just don't trust AI-generated code enough to ship it without a full manual human review. That tells you everything. For all of its raw power, we're clearly missing a reliable process to make what the AI gives us truly ready for the real world.
Okay, so that brings us to our first section. Let's really break down the problem with vibe coding.
And that naturally leads us to section 2, the solution. It all starts with a shift in thinking to what's called the art of context engineering.
So most of us started out with prompt engineering, right? You're basically just tweaking words and phrases trying to get a slightly better single answer from the AI. Well, context engineering is the next massive leap. It's a superset of that idea. It's not about one little prompt, it's about designing a whole system that feeds the AI all the relevant information right at the beginning. Code examples, project rules, database schemas, basically the whole shebang.
So, to put a finer point on it, context engineering is all about building systems that give the large language model the right information in the right format exactly when it needs it. Think of it like you're meticulously packing its context window, which is basically its short-term memory, so that it has the perfect, flawless instruction manual for the job it's about to do.
Here's probably the simplest and best way to think about this. The LLM itself, that's your CPU. It's the raw number crunching power. The context window, that's the RAM. It's active working memory. So context engineering, well, that's the art of writing the software that tells that powerful CPU exactly how to use its RAM to get the job done perfectly.
Okay, so if context engineering is the big idea, the philosophy, how do we actually do it? Well, that brings us to section 3, the PRP Framework.
So what on earth is a PRP? It stands for Product Requirement Prompt. It's a structured framework, actually inspired by how professional product managers work, for creating what you could call a minimum viable packet of information for the AI. The entire goal is to give the AI such perfect, clear context that it can actually ship production-ready code on its very first attempt.
And a PRP has 3 main ingredients. First, you've got the product requirement document, the PRD. That explains what you're trying to build. Second, there's curated code-based intelligence. This gives the AI concrete examples of how your project already works. And third, you have the agent runbook, which is basically a step-by-step instruction manual on how the AI should actually carry out the task.
This whole system works on 2 different levels. You've got your global rules. Think of these as the entire building's architecture. These are the big project-wide principles that don't change very often. And then you have the PRP-specific context. That's more like the detailed blueprint for a single room. It's super specific, dynamic, and tuned for building just one feature.
All right, time to get practical. Section 4, how do you actually build with these PRPs?
The workflow is actually a pretty simple 4-step loop. First, you define a plan for your new feature. Then, the AI generates the full PRP for you, doing all that heavy lifting and research into your codebase. Then, and this is so important, you validate that plan. And only after you've given it the green light do you tell the AI to execute and actually build the code.
And I really cannot stress this enough. That validation step, that's everything. The point here isn't to replace the developer, it's to turn the AI into an incredibly powerful collaborator. You, the human, have to review the plan the AI comes up with. This human-in-the-loop step is the firewall that separates a reliable, robust build from the total chaos of just blindly vibe coding. So you might be asking, why go through all this trouble? Well, that brings us to our final section, number 5, the payoff, which is production-ready code.
This, right here, is the ultimate promise of the PRP framework.
By front-loading all that context, the goal is to generate code that's so good, so reliable, that you can plausibly ship it on the very first pass. We're not talking about a small improvement here. This is how you can potentially 10x your development speed by just cutting out all that endless rework and debugging.
I mean, let's just put it side by side. The difference is like night and day. On one hand, you have vibe coding. It gives you buggy prototypes, the whole process is full of hallucinations and rework. It's really quick to start, but man is it slow to finish. On the other hand, with the PRP framework, you get production-ready code from a reliable, consistent process, which can lead to a development cycle that is just dramatically faster.
And all this brings us to one last really big question. Is this the future of how we build software? This shift from just prompting an AI to systematically engineering its context, it might just be the single biggest leap forward we can make. We're moving from just coding with an AI to truly building alongside it. So the only question left is, are you ready to start building the instruction manual? Thanks for tuning in.